During die casting of high temperature alloys like SG iron in cast iron dies, the use of mold coats is mandatory to control heat transfer from the liquid metal to the mold. The selection of the proper coating material and thickness are important to ensure long die life and optimum productivity. In a case referred to as a series of experiments were conducted to collect thermal data with different coating material and thicknesses. Design guidelines were developed on the basis of the heat flux at the metal mold interface, which were obtained by running inverse solver. A typical guideline could be like a minimum of say 200 micron soot thickness must be ensured for keeping the heat flux at a maximum of 500 kilowatt per meter square. A second guideline could be the die wall thickness must be around 30 millimeters on an average for a 200 micron soot thickness. Such guidelines cannot, however, be taken as universal, as the heat transfer conditions depend on the casting geometry, size, weight. Inverse solver can be used in all cases where process is inaccessible for direct measurement, for the estimation of metal mold heat transfer for casting simulation, efficient design of water or spray cooling systems, selection of mold coat material and thickness in die casting for increased die life, measurement of contact conductance across metallic or non-metallic contacts, measurement of heat flux in all types of welding, friction welding, etc. for quality control, modeling heat transfer coefficient in boiling, condensation, radiation, forced convection, in space technology for design of heat shields and the like, in nuclear technology for design of complex cooling systems. Inverse solver coupled with the newly designed tool reference quench probe can be used for in situ determination of cooling characteristics of quenchants of all types.